Okay, so for part two, we're going to look at the substitution method. So part one, we looked at graphing. Part two, we're going to look at substitution. So here what we do is we solve one of the equations for one variable in terms of the other. So use these year equations. So if you can get one and solve for x or y really easy, just use that one and then substitute it into the other equation. And then we substitute the expression for the variable into the other equation, and then we solve for the last variable, whatever it is, either x or y. And then we substitute whatever that solution is into either of the original equations to find the value of the remaining variable. So if we had solved for x, we solve then for y at the end, or if we had solved for y first, then we solve for x at the end. And then whatever we get out is going to be our xy ordered pair, and that's going to be our solution. And then, like I said, we're going to check our solution in both original equations to verify it is correct. All right, so we're doing by substitution. Well, if I look at the first equation, those are all numbers that can't evenly be divided. So divide by 3, I get 2/3. Here I can divide by 3, but that doesn't help because I have the fraction. But here, if I look, if I divide everything by 5, that's going to come out even. So what I'm going to do is I'm going to take 5x plus 10y equals -10, and I'm going to basically solve for x. So I have 5x then equals -10y minus 10. I'm going to divide by 5 on everything. And I get x is equal to -10 divided by 5 is -2y. -10 divided by that's going to be -2. Okay, so now I've got one of the equations in terms of one variable. And what I can do now is I'm going to take the x here and I'm going to replace all the x's in the other equation with that. So I'm going to take this and plug it into here. So I'm substituting this in place of x in this one. And if you notice, then I'll have a y here and a y here, and I can now solve for y. So I'll take 3 times this value here, minus 2y minus 2, then minus 2y from that equation, and that equals 18. Now I distribute and simplify. So that's going to give me -6y minus 6 minus 2y equals 18. And so now what I have to do is I combine like terms, and so that means get rid of this one. So I'll add 6 to both sides. -6 minus 2 is going to be a minus 8y equals, and here that's going to give me 24. Divide by -8, and so y is equal to a -3. Now, what do I do with that? Well, now I take this value and I can substitute it into one of the original equations and solve for the other one. Now, if I'm really sure that this was solved correctly, I can substitute it simply into here. And if I do that, then I have -2 times -3 minus 2, and that's going to be 6 minus 2, and that's going to give me 4. And so then I have my x and y, so I'm saying now my ordered pair is 4, -3, and that is my solution. But as always, we really have to check in both original equations. So 3 times 4 minus 2 times -3 equals 18, and I'll have 5 times 4 plus 10 times -3, and that's supposed to equal -10. So here I have 12 plus 6 equals 18, so 18 equals 18. That works. Here I have 20 minus 30 equals -10, minus 10 equals -10. That works. So that is the solution to both of the equations, and so that is the solution to the system of equations. Okay. Again, the check's pretty quick on a lot of these, and you verify, yes, you have the correct answer. What about this one? Well, this one I see in the first equation, if I just take and add the 0.2y to both sides, I can solve for x, and then I can just plug that into the second equation. So that's what I'm going to do. So x minus 0.2y equals 1. So if I add, oops, if I add the 0.2y to both sides, then I get x equals 0.2y plus 1. Now I can take this value, or this expression, and plug it into the second equation and solve for y. So I have a minus 10 times 0.2y plus 1, then plus 2y equals 5. Now again, I have to remember to distribute. So 10 times 0.2, that's just going to give me 2, and it's negative, so negative 2y. And then I have minus 10 times that's minus 10, and then plus 2y equals 5. Well, look at that. The minus 2y, let's put this in a different color. Minus 2y cancels the 2y. Oops. And I get negative 10 equals 5. Well, that's not true. That's a false statement. And what did we say about false statements? Well, if there are false statements, then that means there's no solution, okay? And that would be our answer. Now, because there's no solution, no matter what we plug into x here and y here, it's never going to make this statement true. So we really can't check it. And so we really have to be sure on ones with like no solution that it really is, you know, you've done all the work properly, and it would be no solution because there's not a true check unless you go back and do your work again and make sure that that's what you get the second time around. What about this one? Okay, so this one, it looks like I have a y here I could solve for easily, and then I could plug it in here, and then I get x out. So if we take minus 3x plus y equals 2, well, I'm going to add 3x to both sides. And so I get y equals 3x plus 2. Now that means this time I'm going to plug this into here. And so I'll have 12x minus 4 times 3x plus 2 equals negative 8. Now remember, you have to distribute here. So I have 12x minus 8 equals minus 8. And guess what? Once again, we have our x's disappear, but this time we get something else to happen. This time we get negative 8 equals negative 8. Well, what does that mean? Well, that's a true statement, and that means we have an infinite number of solutions, okay? Now, when we have this infinite number of solutions, usually what we do to write this, because you can get an ordered pair out, what we'll do is we'll write it in the format here. So depending on what our x is, we can plug in an x, and if we plug in x, say, into this equation, our y is then just going to be 3x plus 2. And that's how we'll write our solutions when we have an infinite number of solutions. We'll have something like that. We'll have some x we plug in, and our y we get out is 3x plus 2. Okay. Now, if we notice, if we multiply this first equation times 4, that's, or negative 4 rather, if we multiply negative 3 times negative 4, that's 12x, and negative 4 times that's negative 4y, and negative 4 times that is negative 8y. So that kind of shows you that if you multiply one equation by some factor, we can get the other equation. And since they're the same, that means, you know, they're lying on top of each other. So there's going to be infinite number of solutions, and we're going to use the notation x comma 3x plus 2 as our general formula for the solution here. Okay, so that's the end of part 2. I'll come back with part 3.